Okay, let's look at checkpoint 3.2. Problem number one says identify the parent function and transformations for each of the following functions. Carefully graph the parent function and then use transformations to graph the given function, state the domain and range. So looking at this, I see y equals 4 times the absolute value of x plus 1 minus 3. One way that you can identify the parent function is by ignoring the four basic operations of mathematics, that is add, subtract, multiply, divide. So looking at this function, if I see any add, subtract, multiply, or divide, I can just take a moment to ignore it. So here I have some addition. I'm just going to ignore all of that. I've got some subtraction. I'm going to ignore that. This 4 is being multiplied, so I'm going to ignore that. And whatever is left over is our parent function. So I see y equals the absolute value of x. That is our parent function. So I'll say that PF parent function is the absolute value of x. And it says, let's see, identify the parent function and transformations. Okay, so all of those things that I was ignoring, those are going to be my transformations. So this 4 is something special, the 4 being multiplied. The plus 1 is something special. The minus 3 is something special. So I'm going to do the addition and subtraction first. Really, I'm just going to be listing, well, no, I'm going to do the multiplication first. I'm really just listing it all out. I'm going to address that multiplication first. If something is being multiplied by our parent function, it's being multiplied by the absolute value, that's going to be a vertical stretch. So we have a vertical stretch, uh, vertical stretch by a factor of 4, by a factor of 4. You could probably be lazy and just say like vertical stretch 4, or even just like VS4. Um, but yeah, vertical stretch by a factor of 4. Then we also have the adding and subtracting. I'll just read it from left to right, and I'll do the plus one. So since it's on the inside of the function, it's on the inside of the parent function, I know that it's going to be a left-right direction. It's going to be something horizontal. Um, and since it's a plus one, we normally say that the inside lies to you. A plus one, normally people would think, oh, well, to the right on the number line is positive, so it's going to the right. Well, this one's actually backwards of what you might think from that operation, so this is actually going to the left. So we have a horizontal shift to the left one. If you just say left one, that's fine. And then the next thing we have is the minus 3. That is on the outside of the parent function, so it's going to be in up-down direction. I just have to decide if it's up or down. Since it's a minus sign, it's going to be down. So we have a vertical shift down 1. And if you just say down 1, that's fine. Okay, I've identified the parent function and the transformations. Carefully graph the parent function and then use the transformations to graph the given function. So let's see if I can graph this function correctly. The parent function absolute value of x should make a perfect v. I'm going to start by dotting it out. Since I'm trying to draw this on a computer, I probably will not have straight lines. So whenever you're doing it by hand, you should have some sort of straight edge. You know, if you've got a ruler, that's great. Even if you don't have a ruler, if you've got like a credit card or like a student ID, then that would be a perfect straight edge. So I'm going to do my best to draw a straight line. Uh, Good grief. Um, all right, there we go. That's not bad. So I have graphed the parent function. Now I need to use transformations to graph the given function. I am going to address these transformations in the same way that I do order of operations. If we're doing PEMDAS order of operations, we do multiplication first. So that vertical stretch, that 4, that is multiplication. That's the first thing I'm going to be doing, and then I'll do my shifts. I'll do my shifts at the same time, but I've got to do the multiplication first. So every dot that I have, the y value is going to get multiplied by 4. So let's see if I can get a different color going for this transformation. Here we have a y coordinate of 0. So 0 times 4 is still 0. This one is not moving. That one is going to be staying right there. Here we have a y coordinate of 1. 1 times 4 is 4. So my new y coordinate is going to be here at 4. Let me dot that in. Here, this is a y coordinate of 2. 2 times 4 is 8. So we're all the way up here. And if I keep trying to multiply all of these things by 4, I'm going to end up not having room on my graph. Like, really, that's as good as it gets. This y value of 1, I'll multiply it by 4. And then this y value of 2, I'll multiply it by 4. And I can see that my V shape has been stretched upwards. It's almost like someone is pulling on it from above, like a piece of taffy. Um, and it is being stretched. Oh, I'm doing my very best to get straight lines. Oh my goodness. Y'all do this is the bare minimum. Whatever you see here, do better than this. This is okay, but you can do better. Um, Horizontal shift left 1, vertical shift down 1. So I'm going to take all of these points. I like to emphasize them a little bit better. I'll emphasize them in so like this purple point here, this purple point here, this purple point here, this purple point here, this purple point here. All of those, they need to be moved to the left one and also, whoops, did I say down 1? That's not right. Ugh. If you caught that mistake, well done. My bad. It's down 3. Good grief. That's a 3 right there. You're going left 1 and down 3. So I want to move all of those points left 1, down 3. Let's do that in green. So let's go. I'm going to take this point here. I'm going to go left 1 and down 1, 2, 3. Put a point there. Let's make it a little bigger. Can I just? Ooh, yeah. Let's just do that. Ooh, that's way too big. Hold on. That's all right. Okay, left 1, down 3. Boom, point. This one, left 1, down 1, 2, 3. Boom, point. This one, left 1, down 1, 2, 3. Boom, point. This one, left 1, down 1, 2, 3. Point. This one, left 1, down 1, 2, 3. Point. All right. Let me fix that thickness. And I'm going to do my very best to draw a straight line. It's not going to go well. Oh my goodness. Yeah. My points are good. My line is terrible. Use a straight edge. I'm pretty sure I've done it. Identify the parent function, did it, and transformations for each of the following functions, did it. Carefully graph the parent function, I did that in blue, and then use transformations to graph the given function. I did that in steps. In red, I did the stretch first, and then in green, I did the shifts. And state the domain and range. Oh, okay, domain and range. Well, the domain, that's how far left it goes. So the domain, well, this is going all the way to the left and all the way to the right, looking at the green function. There's nothing stopping it from going left and right. It just continues. So it's negative infinity to positive infinity for the domain. For the range, that is how far down it goes and how far up it goes. If I look at how far down it goes, it reaches all the way down to a y value of -3. That's that vertical shift right there. And I can see it on the graph, -3. I am going to make a square bracket because it does actually touch the -3 and it goes all the way to infinity going upwards. There's nothing stopping it from going up. So boom, we have done it.